In order to start a discussion of inscribed angles inside a circle, first a distinction must be made between when you have a central angle and an inscribed angle. So the central angle, the vertex over here is located at the center of the circle, and the sides of the angle are radius of the circle. And the central angle is the easier one. The intercepted arc, if this intercepted arc is 80, then this here is 80 degrees. They're simply equal. So regardless of where I put this, the intercepted arc and the angle measurement are going to be equal. We're going to need this because the way the inscribed angle practice problems appear, they mix the two, where you're given this and then it also has an inscribed angle and they want to know what the inscribed angle's measurements are. Now the inscribed angle, in order to define this one, first I'll give you the definition. This angle here is equal to 1/2 of the intercepted arc. So if the intercepted part of the arc up here is 40, then this angle over here is going to be 20 degrees. And let's take a look at why that's true by giving an example of one that we know the measurements. So here we have the diameter of the circle, and if I was talking about the central angle, I would be talking about this angle over here. So the intercepted part of the arc is going to be 180 because it's half the circle, and this angle over here is a straight angle, and that's also 180 degrees. But now when we talk about an inscribed angle, the inscribed angle has its vertex located on the circumference of the circle, and the two chords that are formed here are where they touch on the circle is the same as this here piece of the hypotenuse of the triangle. This is always going to be a right angle. No matter where I have, I'm going to draw additional chords to show that if I'm measuring this part of the circle here, and that's 180, this angle over here has to be 90 degrees. And it does form a right triangle where the diameter of the circle is also the hypotenuse of the triangle. So in this one, notice the hypotenuse of the triangle is still where the two chords are touching the circle. And this is again a right angle. No matter where I move this to, this will always form a right angle because those two chords are going to intercept this arc over here, which is equal to 180. Therefore, this angle has to be 90 degrees. Now, here is a combination of the two on the same circle, and the only thing that you're given is the measure of the angle, the central angle here, and we want to find this here, and I'll just put an X here. We need to find how many degrees this angle is. So the first thing that I know is that if I am given an angle that's 82 degrees, then this measurement for this arc must also be 82 degrees. And it follows that the theorem for inscribed angles states that this angle is going to be 50% of the measure of the arc intercepted on the circle. So if this is 82, then this one must be 41 degrees. In this example, the only thing that we're given is that this angle over here is 30 degrees, but this is all the information I need to find every angle on here. If this is 30 degrees, then the intercepted arc is also, this is going to be 30. And this part, this here is a diameter, so these are all equal to each other. So that makes this an isosceles triangle. And if this is 30 degrees, I know because this is a straight angle, then this must be 150 degrees. Now, if this is an isosceles triangle, I know 2 times this angle plus 150 is going to equal 180, but I want to do this by looking at the intercepted at the angles that are intercepted here. So anyway, if this is 150, then this part of the circle over here must be 150. Which follows because 150 and 30 is 180, and then this other part up here, this is the 180. So since this part is 30 as a result of this angle, well, then this inscribed angle going from here to here, using this is the diameter and this is a chord, then it must be 50% of this, so that makes this 15 degrees. And this one over here must also be 15 degrees. In this example, we're given both a central angle and an inscribed angle inside the circle, and the only thing that are labeled is the length of these arcs to each side of this figure in here. So if these are both 150 and it's 360 degrees going all the way around, then this side over here must be 60, making angle A 60 degrees. The inscribed angle uses the same arc, length of arc here, so B is equal to 30 degrees. And this might look a little confusing because you don't know, it's not this angle that you're looking at or this angle here. What you're looking at is the central angle is this one here going to the 22, and this one here also going to the same arc of 22. So the picture can be misleading if, you know, there's a bunch of things drawn on there, but this here, they're equal. So central angle is equal to the intersected arc. And this one is an inscribed angle where the vertex is on the circle. So this one would be half of it. So it would be 11 degrees, 22 degrees. This is one of my favorite problems because it's asking for a bit more information than just a typical central angle and inscribed angle. So let's start filling in the pieces of information. We're given that the arc length here is 60, and we need to find angles A, B, and C. So this central angle has to be 60 degrees. And if that's 60 degrees, then angle C must be 60 degrees. There's a number of ways of finding this angle and this angle, and we need that because I need to know how long what the size of these arcs are. But this entire angle here is equal to 180. So 180 minus 60, this must be 120 degrees, which makes this arc 120. And this one, because they're vertical angles, is also 120. This is 120 here. Since I know that this is 240 plus 60 is 300, then this piece up here must be 60 also. Now, if you look, this angle, I'm going to highlight this in red. This angle here, which is an inscribed angle, cuts an arc length that is half of the 60. So this is 150. This measurement must be 75 degrees. And this one, for the same reason, it intercepts this arc here, which is the 120 plus half of the 60, which is 75.